Welcome, my name is Rob Porter. I'm a geometry teacher here at Naperville Central High School. I teach both honors geometry and regular geometry. We'll take a couple of videos, 2 or 3, maybe 4, to take a look at the difference between plane geometry and other types of geometries. And I think you'll find this very interesting. As you study geometry, it's good to know that there's a whole other world of geometry. What you're studying is called Euclidean geometry. Euclidean geometry is named after Euclid, the Greek mathematician who lived in 300 BC. His book, called The Elements, is a collection of axioms, theorems, and proofs about squares, circles, acute angles, isosceles triangles, and other such things. Most of the theorems which you are taught in high schools today can still be found in Euclid's 2,000-year-old book. Euclidean geometry is of great practical value. It's been used by the ancient Greeks through modern society to design buildings, predict location of moving objects, even to survey land. Non-Euclidean geometry is any geometry that's different than Euclidean geometry. Each non-Euclidean geometry is a consistent system of definitions, assumptions, and proofs that describe such objects as points, lines, and planes. The two most common are spherical geometry and hyperbolic geometry. The essential difference between Euclidean geometries and these two non-Euclidean geometries is the nature of parallel lines. In Euclidean geometry, given a point and a line, there's exactly one line through the point that is in the same plane as the given line and never intersects it. In spherical geometry, there are no such lines. In hyperbolic geometry, there is at least 2, and in fact an infinite number of lines that pass through a point and are parallel to, that is in the same plane as, but do not intersect the given line. Spherical geometry is a plane geometry on the surface of a sphere. In plane geometry, the basic concepts are points and lines. In spherical geometry, points are defined in the usual way, but lines are defined as the shortest distance between 2 points that lies among them. Therefore, lines in spherical geometry are great circles. A great circle is the largest circle that can be drawn on a sphere. The longitude lines and the equator are great circles of the Earth. Latitude lines, except for the equator, are not great circles. Great circles are lines that divide the sphere into 2 equal hemispheres. Spherical geometry is used by pilots and ship captains as they navigate around the globe. Working in spherical geometry has some non-intuitive results. For example, did you know that the shortest flying distance from Florida to the Philippine Islands is a path that crosses Alaska? The Philippines are south of Florida, so why is flying north to Alaska a shortcut? The answer is that Florida, Alaska, and the Philippines are all collinear locations in spherical geometry. That is, those points lie on the same great circle. Another odd property of spherical geometry that we'll discover is that the sum of the angles of a triangle is greater than 180 degrees. Small triangles, like those drawn on a football field, are very close to 180, but big triangles, like the triangles between New York, LA, and Tampa, are significantly more than 180. So let's just take a look at these spherical geometry differences. And what you'll see, I think what you'll find interesting is that if you have lines in plane geometry, like these, they're straight. But if you have lines in spherical geometry, they form a great circle, like this. And that great circle then wraps around and then attaches to itself. So a line in plane geometry is infinite, while a line in spherical geometry has a particular distance. It's finite. So we're going to talk a little bit more about lines and segments in between this in the next video segment. So I hope this keys your interest, and hope to see you in the next video.